A family of quadratics all have a vertex existing on the line x equals 3. Therefore, the general equation for that family is y equals a times x minus 3 all squared plus k. So we want to determine the equation of a member which has a range between 5 included up to infinity and passes through the point 5, 11. So first of all, let's start to understand what this means. So if we consider the set of axes here, we know that it has a turning point on the line x equals 3. So if we put the line x equals 3 in here, we know that we can have a parabola that is something like this, or like this, or like that. Anything that has its turning point on that line. So the next piece of information says that we have a range of 5 to infinity, which means that our parabola, if we get rid of these possible orange ones, must have a turning point when x is 3 and y is 5. Now, it could still be quite shallow or quite broad, alright? So we need to determine the value of a, which is the dilation factor, such that it goes through the point 5, 11. So the point 5, 11 is somewhere around up here. So to do that, what we're going to do is we're going to substitute in all the things we know into the general equation for the family. So we know that the general equation is y equals a times x minus 3 all squared plus k. And now the first thing we knew was that y equaled a times x minus 3 plus 5. And that plus 5 here comes from the fact that the range has a minimum value of 5 and it goes up to infinity. We also know from that that a must be positive. So a must be positive. So the next thing we can do is we can substitute in the point to find the value of a. So we're going to substitute the point 5, 11 into the equations. So we're going to find that 11 is equal to a times 5 minus 3 all squared plus 5. So therefore 11 is equal to a times 2 squared plus 5. So therefore 11 is equal to 4a plus 5. And now if we subtract 5 from both sides, we get 4a is equal to 6. If we divide both sides by 4, divide both sides by 4, we find that a is equal to 6 on 4, which is the same as 3 over 2. So now that we've found this, it's just a matter of substituting all the information into the general family equation to find this specific member. So we know that y is equal to a, which we found to be 3 on 2, times x minus 3, all squared, plus 5. And that's the equation of the specific member that we were looking for.